Alright, so this video is going to be on solving systems of linear equations using substitution methods. So first of all, there is quite a good deal amount of basic things you need to know. So let me just go through those really quickly. So basics. First one is distributive property. So essentially what I'm saying to you, if you have this value times a quantity, that you simply take the value on the outside and you can multiply it by each term on the inside. So I can do this a times b plus this a times c. So that's distributive property. So basic essential number one, you'll understand that when I do some problems. Other one is properties of equality, and basically all I want to get at here is that if I want to undo operations, that I must make the inverse operation. And essentially when you're solving equations, you're trying to make zeros and ones. So here we go. So if I want this 2x to be by itself, and I'm adding a 5 to it, then I must do the inverse of adding, which is subtracting 5, and the property of equality states that if I subtract 5 from one side, I must subtract 5 from the other side. And then I now simplify this expression, so I will get 2x plus 5 minus 5 is just 2x equals, and then 20 minus 5 is 15, and what I'm now left with is I have 2x and I want to turn it into 1x. Well, if I have 2 times x, then I must use the inverse operation of multiplication, which is good old division. So I divide by 2, and I get this good old thing here that's x. Oops, wrong one there. I'll get that x is equivalent to whatever 15 divided by 2 is. Now you can leave it as a rational expression, which means you can leave it as 15 over 2 because it doesn't simplify, or you could write this as 7.5. So whichever one you want. So properties of equality. All right. So moving forward, transitive property. So why is a transitive property important? And it's because it sets you up for the idea of substitution property. So idea is if A equals B and B equals C, then by logic it will be true that this A must be equal to C. Okay, because if I have two things equal to the same thing, then they themselves must be equal. So then we move forward. So that takes us into the substitution property. And the substitution property, okay, is not the transitive property. Transitive property is two things directly equal to each other. Substitution property is if I have this A plus B equals C, and I'm letting you know that B equals D, then it must also be true that A plus D must also be the same thing as C. So basically the logic piece behind that is it doesn't matter whether I do A plus B or A plus D to get C, because B and D are going to be the same number. So that is your basic ideas that you need to have. So moving forward. So if any of those skills are lacking, the rest of this might be a little bit harder to do. So let's move forward now into doing some of these problems by solving systems of linear equations by substitution. So we're going to solve the following system, and the system says to you x plus y equals 12, and then I have y equals 3x. So basically the important thing here is the substitution, which means I have a variable being set equivalent to something. I don't have like an expression being equivalent to something. When I was talking about previously, all right, was that A plus B equaled C, and then I told you that B could have been replaced as something else. So in this problem, I have this x plus y equals 12, all right, and then the second part of the system says y equals 3x. So this is where I'm defining for you, okay, that this piece here defines for you that anywhere a y exists, we can replace, okay, we can place 3x, okay, because we just told you that y equaled 3x. So anywhere I see a y, I can now swap out for a 3x. So we'll go ahead and do that. So we start off with this equation of x plus y equals 12. And anywhere I see a y, so I'm going to highlight this, that I have a plus y. All right, I can now just be writing, instead of y, I can, as the sentence says, I can just write it as x plus 3x equals 12. All right, and then why is this important? Because this now allows me to have an equation I can solve, because you can't solve an equation that has more than one variable in it. So you have to get it down to with just one variable. So I took the y out and replaced it with x, so now I have a bunch of x's. So now I can go ahead and I can combine those two into 4x and say that that equals 12. And this is where those properties of equations come in. How do I simplify, or not simplify, how do I get x by itself? I use divide by 4. I now have x equals 3. So In a system, if you notice, the equation is made up of x's and y's, not just x's. So as of right now, I only have one part of the system, and I have the x of the system. I also need the y of the system. Well, if you look up here again, I'm also defining how you find y. So y is found by doing 3 times x. Well, I just discovered that x was 3. So I do y equals 3 times 3, and I'll get y equals 9. All right. Now, this wouldn't be the first thing that your teacher introduced to you. The first thing they introduced you was probably graphing, and they talked about what a system is and what you're finding. So you should know at this point that a solution to a system is an intersection point. So you should be in the habit of writing that this is a coordinate pair of 3, 9, where that is the exact point on a graph where the equation of the line of x plus y equals 12 will intersect the line of y equals 3x. So let's go on to another one, make them a little bit harder and add a little bit more properties into them. Okay, so new system. The new system is x equals y plus 1 and x plus 2y equal 13. So again, all right, the one here that we're looking for is this thing that says a variable is equal to something. So right now what I'm seeing is that this x, okay, anywhere I see x, I can write y plus 1 in its place because I'm telling you that x is y plus 1. So what I do is I go to the second equation. The second equation is this x plus 2y equals 13. And anywhere I see an x, all right, so I can, instead of writing as x, I can write it as this y plus 1. So in here I go y plus 1, all right, plus 2y equals 13. So I'm just highlighting the fact that I have that y plus 1 there. So why again is this important? Because now instead of having an equation with two variables in it here, so instead of having two variables of an x and a y, I now have y's together. So now I have an equation that I can go ahead and solve. So I'm going to go ahead and I'm going to combine like terms here. So 1y and 2y's make 3y. Plus 1 is just plus 1 equals 13. So now I'm back to solving an equation. So minus 1, because I'm adding 1, so minus 1. And I get 3y equals 12. So to do the property, I divide by 3, and I will get y equals 4. So again, once I have y equals 4, I now can go back, okay, to where the equation has that defines for me how to find the x. And the x is going to be y plus 1. So down here very quickly, x is found by taking this y plus 1. I just determined that y was the value of 4, so x equals 4 plus 1, so therefore x equals 5. So again, my final answer to this one is going to be the coordinate pair of 5, 4. So the coordinate pair 5, 4 is where these two intersect. All right, so let's look at one more to finish up this video. And one of the things that, before I do this last problem, I just want to make sure you're cognizant and aware of is that you're always looking for this thing that says like y equals x equals. You're looking for a variable being equivalent to something. So wherever you see that variable, you can go ahead and replace that variable. So in this problem, again, I'm going to take a look at this, and I have, okay, my statement here is y equals negative x plus 3. So anywhere I see a y, I can swap out the y and put in the quantity of negative x plus 3. So we go down here, and I've got this equation of 2x minus y equals negative 9. And now wherever I see a y, so here's my y, and notice I'm not taking sign with this, okay? This sign stays put. It's just the actual variable that I'm just swapping out. So in this case, right, I'm going to have this 2x minus, and I'm going to swap in there, okay, this negative x plus 3. So what's important here is that this is a quantity. It must travel together. And when quantities travel together, the way you keep them together is you put them in parentheses. So that's an important piece here. So I'm going to go ahead and I'm going to go through here, and I'm going to put this in parentheses. I'm going to go negative x plus 3. And then I'm going to go ahead and set that equal to my negative 9. And now from here, all right, I'm going to now utilize the distributive property. So distributive property is, this is a negative in front, so it's a negative 1. So distributing it through, I now get this 2x minus a negative and a negative turns it into positive. So positive x, negative 1 times positive 3 makes negative 3 equals negative 9. So again, from here, I'm just going to go ahead and I'm just going to take these two things. I'm going to turn them into 1, so combining like terms. So I get 3x minus 3 equals negative 9. And now we're back to solving this equation, right? So add 3 to both sides, add 3 to both sides. And now I'm left with 3x, because those cancel out, is equivalent to negative 6. Last step is to divide by 3, and I get x equals negative 2. So once I have x equals negative 2, I want to find the y coordinate. Okay, so I go back up to this one, and I pluck that back out. So I'm going to write that back down here. And then when I write it back down, I get y equals negative x plus 3. And then the final step here is to plug the negative 2 in. So y equals, now it's a negative, so put the negative there. It's a negative x, so whatever the x is, I have to put a negative. Now place your negative 2 in there as well, plus 3. So notice if there's a negative already in the problem and I have a negative, it means I must have two negatives now, right? If there's one there, I'm placing another one. You must see the two of them. So now I get y equals 2 plus 3, because two negatives make a positive, and I get y equals 5. So my final answer to this one is going to be the coordinate pair of x is negative 2, y 5. So again, these two lines intersect at the point negative 2, 5. And that is the substitution method. So I hope you understand that the bare essentials to this is this idea of taking out one variable and swapping in what you're telling me that I can swap in for it. And yeah, from there, so I hope that helped.